In this video, we will look at knowing and using the relationship between acceleration, velocity and time. As we have seen before, knowing the equation means you must be able to recall it in the exam, and therefore you must learn it off by heart. Using an equation means you must be able to 1. Rearrange it, 2. Substitute in correct values and completing any necessary unit conversions, and 3. Make the final calculation. The first method of rearranging we will look at is the triangle method. This vertical line represents multiply, and these horizontal lines represent divide. To use the triangle, you cover up the part of the equation you are interested in, i.e. the one you want to calculate, and you look at the remaining equation. Let's look at an example. A car accelerates for 10 seconds at 0.5 meters per second squared. Its initial speed was 2 meters per second. What is the new speed? To find the new speed, we need to first find the change in velocity. So, we cover this up, and we see that the equation is acceleration multiplied by time. Putting in the numbers, this gives us 0.5 meters per second squared times by 10 seconds. So the change in velocity is 5 meters per second. Overall, the new speed must be the initial speed plus the change. So in total, our new speed is the 2 meters per second plus the change of 5 meters per second, giving a final answer of 7 meters per second. A second way to rearrange the formula is to use the same rearrangement methods that you've used in maths. We can view this equation in its symbol form as A equals V minus U divided by T, where A is acceleration, T equals time, U equals the initial speed, and V equals final speed. V minus U is the final speed minus the initial speed, so this represents the change in speed or the change in velocity. Knowing this equation means we can rearrange it to make V, U and T the subjects of the equation and therefore find any quantity that we wish. Let's have a look at this more closely. The equation is already in the form with acceleration as the subject, so we don't need to rearrange for A. However, we'll rearrange it for T, V and U. To make T the subject, we need to first bring it to the other side. Here, it is a divide by T, so when we take it to the other side, it'll become a times by T. We then need to take A to the other side, leaving T on its own. It is a times by A here, so when we move it to the other side, it becomes a divide by A. We can do this in a single step by just swapping the position of A and T. Now let's make V the subject. Start by taking T to the other side, as we did before. And now we need to move U to the other side, so V is left as the subject of the equation. It's a minus U on this side, so when it goes to the other side, it becomes a plus U. Finally, let's make U the subject. Make the same first two steps as before. But now we will move the AT to the other side, leaving U on its own. And that's it. This method is harder than the triangle method, but by mastering it, you are practicing a skill that will serve you well throughout the whole course. Let's look at one final example. In this example, a car accelerated at 2 meters per second squared for 3 seconds. Its final speed is 50 meters per second. What was its initial speed? We are going to use the second method of rearranging, so we want to make u, which represents the initial speed, the subject of the formula. So here goes. U equals 50 meters per second minus 2 times 3. We need to make sure we do the 2 times 3 first. So our final step is 50 minus 6, giving us an answer of 44 meters per second. That's it for this video. We'll look at an example exam question when we've finished velocity time graphs.